Hello, this is video C. For CES2, CES 2124, and C++. What a coincidence. C++ syntax. This is stuff we need to know to be able to write programs. Syntax just means the rules of constructing valid statements in the language. Some of the C++ syntax we need to know, we got to know main, M-A-I-N. I'm going to treat that as if it's a statement. Actually, what it is that what's called a standard identifier is similar to a variable, if you remember variables from other higher level languages. It's just a word in the program, but we have to use main for the main program in C++, so we can't use it as a variable or anything else like that. The format for the main statements, had to put air quotes around that because it's not technically a statement, is this: int, space, main, M-A-I-N, and then parentheses, void, close parentheses. Those of you coming from a Python background, this is the replacement statement for def main parentheses colon. Remember that always marked, that was just, we could just do that automatically. That was always the beginning of the main program. This is always the beginning of the main program. And that's what I'm going to put for the effect of this, air quotes, statement. Marks the beginning of a program. I don't know how much of this I'm actually going to try to write. That really slows things down, doesn't it? This statement, int main void, marks the beginning of a program. I'm not going to write down all this, but I'm going to point at it and talk about it. Main is our standard identifier that says, you know what, this is the main program. Int says this program is going to return or send back to the operating system an integer value, which is a whole number, like 7 or negative 25 or 0. Normally we're going to be returning 0, which back in the olden days, when all C programs were run on Unix systems, Unix was sitting there, the operating system was sitting there waiting for the program to send back something to say whether or not an error had happened. So this business of returning an integer, that's almost a legacy thing now in C++. We just sort of, by default, automatically send back a 0, say, you know what, nothing happened, don't worry about it. But that's what that's for. Void, on the other hand, means we are not expecting the operating system, Windows or Mac OS or OS X or Unix, to send us anything in. So this, in parentheses, would be where the operating system, remember the operating system gets to decide what, well, maybe you don't remember, but take my word for it. The operating system gets to decide which program runs next. And am I going to run the loader because they clicked on the icon and pull that program into memory? If they do that, if the operating system says, you know what, I am going to recognize the clicking of the icon and pull in that program and put it in memory as a core image. Now we're going to start running it. What it does to start running it is to what's called call our main program. Main, it's your turn, you can run now. And main, we'll look in parentheses to see if the operating system sent it any little bundles of joy, any packages of data that it's supposed to use. Again, this is just kind of a legacy, almost a fossil of a statement from times past, because this is always, in our case, this is always going to be void. It's always going to be int main void. We're not expecting to get anything passed in from the operating system, and then just kind of, you know, at the end, we're not going to send you anything back except a 0. So you didn't give us anything, we're not giving you anything, but this still has to be there. Int main void marks the beginning of a program. I don't know what else to say about that. Here's another statement that isn't really a statement. Curly brackets. It's easy to say, but for me, it's kind of hard to draw. Curly brackets, the format for this, you know what, I'm going to keep my int main void statement because it's an integral part of that, at least in this example. Int main void, those are not curly brackets. Here are the curly brackets. The curly bracket, open curly bracket says, okay, here come the statements of my main program. Statement, 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 statement. And then a closing curly bracket says, that's all, folks. So all of the statements that are between the curly brackets, that's what constitutes your main program. So there, that's the syntax. The effect of curly brackets, therefore, if you've got all that weird description, they enclose the body of the main program. Enclose the body, the fancy word for the set of statements, the body of the main program. Now, curly brackets actually show up in other places beside the main program. Again, coming from a Python background, everywhere the indentation made a difference. I've got an if statement. Now I want these statements to only be executed if that if condition is true. I had to indent all those by the same amount. Indentation, for better or for worse, doesn't really matter in C++. The way you put stuff together as a package deal in C++ is to use curly brackets. That shows up so often, has its own term. Statement block. Statement block. B-L-O-C-K. Statement block, I'm defining a term here, is a sequence of statements enclosed in curly brackets. A sequence of statements. Heavily abbreviated, get used to this. A sequence, S-E-Q, of statements, S-T-M-T-S, sequence of statements enclosed in curly brackets. What? How on earth am I going to reduce all this writing I have to do, which is really slowing these videos, isn't it? Well, here's how I'm going to do it. I use a lot of abbreviations and a lot of shorthand and a lot of tokens. I'm going to have, for example, my own convention, in other words, my own homemade rule of I can put things inside pointing brackets and kind of finesse away the actual details. Let me show you what I'm talking about here. Here's format 2 for the main program. Format 2, int main void. See how I got that memorized? There are not a whole lot of things I've got memorized, but I got that. Int main void, and then pointing brackets. S-T-M-T-B-L-K. I'm going to claim to you that this is exactly the same thing as that. This says the format for using curly brackets to define the beginning and end of the main program are open a curly bracket, do all your stuff, put all the statements, then put a closing curly bracket. This is saying the same thing in a different way. If we all remember, let's just agree to remember, if we all remember that a statement block is a sequence of statements enclosed in curly brackets, then this is a somewhat shorter, perhaps, way to write that. This says int main void and then a statement block, which is a group of statements enclosed in curly brackets. I use this pointing bracket stuff to separate out a token or something that has to be replaced with the real thing before it makes any sense to the computer. I'm going to be using this heavily throughout our summer semester. So that's one more thing to get used to. Let me see. Is there anything else to say about the purple stuff that's on the board right now? I don't think so. So let me see how quickly I can get rid of all this. We're still C++ syntaxing. Actually, we're going to be doing that until further notice. So until I tell you we're doing something different, this is all C++ syntax. This is actually a statement in C++. The word return. Return is an example of a reserved word, meaning it's a word that already means something in C++. For, that we're going to use in for loops, that already means something in C++. Int, that means integer, a whole number, that already means something in C++. There, return is the same way. Return statement, the format for that is this. Return. Look what I'm going to do. I'm going to use my pointing bracket convention. It just looks like a less than and a greater than, and put value here. V-A-L-U-E. Now, what's the significance of the word return not being in pointy brackets. That means, I use that verbatim. What you see is what you get. I got to type in the word return. What is the significance of value being inside pointy brackets? I've got to rip that out. That's a stand-in. That's a token. I've got to replace that with a 0 or a 9, or maybe I'm returning the word cat, whatever it may be. Whatever's going to be returned by the return statement would go here. The significance of the big fat semicolon that I intentionally made bold is almost every single C++ statement that is not the curly brackets or parentheses or something, almost every C++ statement has to end with a semicolon. That's how the compiler, referring back to the previous video, that's how the compiler knows it's reached the end of the statement. Uh-oh, my video is acting up. I hope that you got all that. I'll repeat that last statement just in case. That's how the compiler knows that it's reached the end of the statement when it hits a closing curly bracket. The effect and it's almost redundant the way I'm going to write the effect, returns value, whoops, almost left off the curly bracket, returns pointy brackets value to the caller, C-A-L-L-E-R, and I said that weird because I haven't defined what a caller is yet. The caller is whoever passed control of the CPU to us. The only example we've even discussed briefly is the operating system. The operating system calls your main program. Your main program does all this stuff, yada, yada, yada. And at the bottom, for example, at the bottom, it might very well have the statement return 0. Meaning everything is A-OK, everything is good to go. We are returning 0 to the caller, who in this case would be the operating system. 0 is playing the role of value in that example. A lot of this stuff, I know these statements are ridiculously easy. A lot of this is to introduce the weird, quirky way I write these things down, using a lot of abbreviations and tokens and all that sort of stuff. Okay? Well, all of that is C++ syntax. Let's get going. We're going to write some programs. Our first C++ program. I don't know about you, but I'm excited. I'm not even sure we're ready to write a C++ program yet. Let's give it a shot. Int main void, we know that's got to be there. Open curly bracket, beginning of a statement block. Review, we're going to send back a number, we're going to receive nothing. We don't actually know a lot of stuff we could put inside that program, but we got a return statement. Int main void return 0 with a big fat semicolon and a closing curly bracket. Ladies and gentlemen, I present to you a complete C++ program. Doesn't do a heck of a whole lot. What it does is, for one brief and shining moment, it has the complete and undivided attention of the CPU. That's it. When we click on the icon or tell the, I'm going to quit talking about icons. When we run this program, we are telling the operating system, okay, pass control of the CPU to this program. Don't send it anything. And the main program, it actually has a fraction of a microsecond, has control of the CPU, and what does it do with it? All it does is send back a 0, because it promised it would send something. When we put int out here, we are making a promise that we are going to send back a number to whoever called us, whoever allowed us to run. In this case, we're just returning a 0. So that is, believe it or not, a complete C++ program. Yeah, we're going to have to learn some more stuff if we're going to make our programs a little more interesting. Another C++ statement. These are important comments. And it almost seems like a contradiction, the way I'm going to describe it. The format for a comment, not phonet, F-O-R-M-A-T. Format is 2 slashes. And then here's a token here. But I could type this in verbatim if I wanted to. Ignored text. Oh, I misspelled text. Oh. You know what? That doesn't even matter. I'll fix it. Ignore text. But the reason it doesn't matter is because it really is ignored. When the compiler sees these two forward slashes in a row, it kind of takes a break mentally and ignores everything to the end of the line. Ignored, I-G-N-O-R-E-D, to end of line. Now, here's where the perhaps irony comes in, or seeming contradiction. Why did I say that's important? C++, even though it's going to become your new second language, if not even your new first language, it is not self-explanatory, regardless of what you may think. You've got to put comments in there to explain what your code is doing. Maybe not one comment per line, maybe not every single thing, but very close. I would say one comment for every 6 or 7 lines, and it's getting perilously long, your sequence of statements. If you've got more than 7, if you've got 10 or 20, then you might not have enough comments. And I'm introducing the format here, and the effect of this, if I were to write it down, is the effect is nothing. It doesn't change how your program operates at all, but it makes it a lot more readable to other humans and to the you of the future that comes back and tries to read your code later on. We will see examples of that when we see example program. But in order to slip that in there fairly soon, because it's pretty important, not a statement, but a definition. This is the next thing, by the way. In C++, an identifier, I-D-E-N-T-I-F-I-E-R. An identifier is a string of characters, S-T-R-I-N-G, of characters, A-C-T-E-R-S, used to name a variable, a function, a symbolic constant, abbreviated symbolic constant. I know we don't know what these things are yet necessarily, but, and I'll put in a second because I left a bunch of stuff out. What do all those things have in common though? This is anything that the programmer has to invent a name for. Anything the programmer, that would be you, by the way, the programmer, whatever I said, must invent a name for. Now this is still kind of review because this is not unlike other high-level languages that you might have some acquaintance with. But there's some rules we've got to follow. I'll state the rules, and then I'll just illustrate the rules using examples. Here's rule number 1. It's got to begin with a letter. Examples. Okay example, not okay example. Okay example, Coke, C-O-K-E. Now, a string of characters. I didn't define that, did I? A string just means a sequence. They're all stuck to each other. Characters, you can think of a character as the symbol that you get when you poke the keyboard. Capital A is a character. The question mark. Ooh, mysterious. That's a character. The minus sign, the space even. Now, we can't use spaces in variable names. They've got to all be stuck together. But in this case, let's see. The string of characters has got to start with, what did I say? Begins with a letter. It's got to start with a letter. As opposed to what? Not okay, 7-Up. You might prefer 7-Up to Coke, but you can't use 7-Up as a variable name because it doesn't start with a letter. There. Rule number 1. There's 3 rules. Consists of letters and digits only. No spaces, no plus signs, no minus signs. So you could have Rugrats. That's an okay variable name, as long as it doesn't have any spaces. You can't use Ren and Stimpy. Huh. Why not? Well, Rugrats starts with a letter, doesn't have any stray characters in it, doesn't have any non-letters in it, doesn't have any. Now, actually, I could use Rugrats 9 if I wanted to. I can do that. As long as the 9 doesn't come in the front, it's okay. It's got to start with a letter, consists of nothing but letters and digits, letters and numbers. The ampersand is what blows this one over here. Can't use that because that's not a valid identifier. And one more rule, it can't be a reserved word. What's a reserved word? Well, an okay one would be leave. I can use leave as a function name, a variable name, whatever I want. Not okay is return. You can go, but you can't come back. You can leave, because leave doesn't already mean something in C++. It's not a reserved word. You can't use return as a variable name because it is a reserved word. That already means something in the C++ syntax. See how to play this game? So since I'm feeling really bad about not writing those down, but let me review these for my own sake, if not for yours. An identifier, a valid identifier for a variable name, function name, whatever, has to start with a letter. Wrong. Has to consist of nothing but letters and digits. Wrong. Can't be a reserved word. Wrong. And just out of habit, if nothing else, I've been using a convention called camel casing. I'll write that down here. Camel casing. And I'll just do an example of camel casing. A, and weird, W-E-I-R-D with a capital W, way with a capital W, of, capital O, a weird way of naming with a capital N. You can infer or reverse engineer or figure out backwards what camel casing means. A weird way of naming with two capital W's, a capital O, and a capital N. It's like a camel's humps. It's like a Dr. Seuss camel that's got, in this case, 1, 2, 3, 4 humps. You start with a lowercase letter, and every other word that you squash together, remember you can't separate these words using spaces, because variables and functions, that looks like a space there. I'll squish that 9 over there. There! No spaces allowed. So to kind of make up for that or accommodate for that, this is a convention. Got to define convention. There are rules that have to be followed, like these rules of constructing variable names. Those are syntax rules of C++. A convention is weaker than that. It's not, if I made nothing but lowercase letters, if I used nothing but lowercase letters in this variable name, it would still work. It would not be consistent with the camel casing convention, which is like a gentle person's agreement. Let's all agree to do it this way so that our code looks more similar and more readable and more professional. Conventions are unspoken rules, ways of doing things. Like if we were back to normal, maybe someday, if we were back to normal at school and everybody was just madly rushing to get to their next class, a convention is everybody is probably going to stay to the right. So you're going one way down the hallway, everybody's staying to the right, the other direction, they're all staying to the right, and it's on the other side of the hallway. Conventions can be really handy, even though they're not laws, they're not strictly enforced. Conventions can be really handy for just streamlining things, making it easier. And if everybody agrees to do it that way, even though we don't even discuss it, then it just makes life a lot easier. I spent a lot of time talking about conventions, didn't I? Conventions are going to show up a lot. I'm going to say when we get to the point where we are actually describing and defining objects, for crying out loud, and we will get there after we know basic C++, the conventions, we're going to talk about those probably more than the syntax. We will leave the basics of the toolbox behind and talk about the sets of conventions that make spaghetti programming, transform that into professional software development. The difference is not syntax. It's not whether or not you use for loops. It's whether or not you adhere to conventions. So even though this is our first example of a real live convention, it's important that we understand what those things are and why that's important. None of these do anything This is all just set up here. These are basic tools. So I'm going to call this the end of the setup video, our first one in C++, and I'll pick up with statements that actually do something, for crying out loud, with the next video. And that's it for now. I'll see you online.